Today we're going to be looking at multi-step equations, specifically equations with the distributive property. So a multi-step equation is an equation that involves more than one step. Steps to solving equations with the distributive property. First, we are going to eliminate the parentheses. Just like in order of operations, we get rid of the parentheses first. Then our next steps are just like when we had two-step equations. We are going to add or subtract to eliminate the constant. And then step 3, we're going to multiply or divide by the coefficient. So again, this is a general process here. We're saying these are the general steps. It could change problem to problem, but generally speaking, this is the steps that you're going to follow. So looking at example 1, drawing my line down my equal sign, I'm highlighting my variable. On the side with the variable, we see parentheses, so we need to distribute first to get rid of the parentheses. I'm multiplying the 8 by both terms. Be careful when you're multiplying so that you're thinking about those negative values. We're doing 8 times positive 2x, which is 16x. Then we're doing 8 times negative 3, which is negative 24. Equals, and then we bring down the negative 56. Now we have a basic two-step equation that we can solve. We're going to get rid of our constant. We have negative 24. We're going to get rid of that by adding 24 to both sides. It's going to cancel out on the side with the variable. We're left with 16x equals negative 56 plus 24 is negative 32. Then the last step, x is being multiplied by 16, so the opposite is to divide each side by 16. It's going to cancel out on the side with the variable. We're left with x equals negative 32 divided by 16 is negative 2. All right, number 2, drawing our line down the equal sign, highlighting my variable. The variable is on the right side of the equation, and there are parentheses. So first thing I'm going to do is I'm going to distribute the 1.5 to both terms. You can use a calculator to help you if you'd like this, since it's decimals. We're doing 4 times 1.5, which is 6y, and 1.5 times 17 is 25.5. Equals, bring down the 36. Now we have our basic two-step equation. We're going to get rid of our constant. We've got plus 25.5, so I'm going to get rid of it by subtracting 25.5 from both sides. Those cancel out on that side, so we're left with just 6y over there. And on the left side, 36 minus 25.5 is 10.5. And then our last step, our y is being multiplied by 6, so we're going to divide each side by 6. It cancels out on the side with the variable. We're left with 10.5 divided by 6 is 1.75. All right, number 2. We are going to take, draw our line down the middle, highlight our variable. Our variable's on the left side. We need to get rid of the parentheses over there. Be really, really careful when you're distributing here. We have a negative 6, we have a positive 3g, we have a negative 5 when I'm distributing. So negative 6 times positive 3g is negative 18g. Negative 6 times negative 5 is positive 30 equals 102. Now we've got our basic two-step equation. We're going to get rid of our constant. Since it's plus 30, we're going to subtract 30 from both sides so we can eliminate it, because 30 minus 30 is 0. Bring down what's left over here, negative 18g equals 102 minus 30 is 72. And then our last step, g is being multiplied by negative 18, so we're going to divide each side by negative 18. It cancels out on the side with the variable. 72 divided by negative 18 is negative 4. Number 4, drawing my line down the equal sign, highlighting the variable. Negative 12 is being distributed to both, so make sure we're doing that negative value. Negative 12 times positive 3x is negative 36x. Negative 12 times positive 8 is negative 96. And then bring everything else down. Next step, we're going to get rid of our constants. We have minus 96 or negative 96. We're going to get rid of it by adding 96 to both sides. It should cancel out on the side with the variable. Bring down the negative 36x. And then negative 6 plus positive 96 is going to be positive 90. And last step, x is being multiplied by negative 36. We're going to get rid of it by dividing by negative 36 on both sides. It's going to cancel out on the side with the variable. And then 90 divided by negative 36 is negative 2.5. All right, and then the last ones we're going to look at are ones with fractions involved. So there's a couple different ways that you can go about solving these ones. I have just kind of a recommended way to go about it, but that's not to say that that's the only way that you can solve these types of problems. So let's go ahead and solve them. So let's solve this one the first way, the way that we've kind of been doing it. We've got a negative 5 on the outside, so that needs to be distributed to both terms. So I'm going to actually kind of write out what I'm doing here. So we've got negative 5 times x, and we've got negative 5 times 3/5. So the negative 5 times x is just negative 5x. Over here, negative 5 over 1 times 3 over 5, that's going to cancel each other out, and we're left with negative 3 over 1, or just negative 3. And then I bring down the negative 4. Then here, we've got minus 3 that we need to get rid of, so I'm going to add 3 to both sides. It should cancel out over here. I'm left with negative 5x equals negative 4 plus 3 is negative 1. And our last step is being multiplied by negative 5, so I'm going to divide by negative 5 on both sides. We get x equals positive 1/5. So that's one way to solve that problem. I'm going to do the same problem, but I'm going to solve it a little bit differently. So if we've got our problem, which is negative 5 times x plus 3/5 equals negative 4. So it happened to work out pretty nicely here that it canceled out and it wasn't that difficult to do. But sometimes it's not going to work out that nicely, so it can be easier to do it a little bit differently. What we can look at is this whole entire side of the equation is being multiplied by negative 5, so the opposite would be to divide this whole thing by negative 5, because that will actually cancel that out, and all that you'll be left with is x plus 3/5 equals, and over here, we're just dividing by negative 5. Well, negative 4 over negative 5, we're just going to rewrite that as a fraction. Negative divided by negative is a positive, so we get 4/5. Now I just have a basic equation where I have addition, I need to subtract. They already have common denominators, so I'm just going to subtract 3/5 from both sides. It's going to cancel out on this side. I'm left with x equals 4 minus 3 is 1. In my opinion, doing it this way was a little bit quicker. There were less steps, but the other way might work for you as well. Number 6, same thing. We've got a fraction. So I'm going to do it that second route because I think that's going to be a little bit quicker. So I've drawn my line down. So we're going to do our first step of drawing our line down the middle. And then I'm going to solve this one doing it the second way, where I get rid of the fraction first instead of distributing. So we've got 3/4 on the outside. It's being multiplied, so I'm going to divide the whole thing by 3/4. On the side with the variable over here, these should cancel each other out. We're left with just 8 minus 7x. Over here, I need to keep it, switch it, flip it. Now I'm going to double check my diagonals to see if anything simplifies. When looking at this, I see that 15 and 3 divide by 3. 4 and 1 divide by 1. So we get 3 over 1 times 5 over 1 times 4 over 1. Then I'm going to simplify that to -5 times 4 is -20. And I'm bringing everything else down. So 8 minus 7x equals -20. Now, we've just got a basic two-step equation. There's no more fractions in here. So I'm going to get rid of my constant by subtracting by 8. Don't forget, this is a -7x that's left over. -20 minus 8 is -28. And then last step is to divide by -7. It's going to cancel out on the side with the variable. We'll be left with x equals -28 divided by -7 is +4. So again, you could have done it the other way where you distributed first, but then there's just more fractions to deal with. So I think this method was a little bit easier.